You're welcome once again. This is Solomon at Solo for Math. We are still looking at this series about differentiation, and today we want to look at product rule, another method of differentiation. When do we use a product rule? If I may give an example, if you're given a function y equals to x plus 1 into maybe 2x minus 3, and then I ask you for the derivative for you to find y dx, one would think about expanding this, which is okay. Expand, then you differentiate individual terms, and then you sum them up. Or when you're given y equals to x squared plus 1 into x squared, the same thing. You can easily think about expanding this and then differentiate individual terms using the method we learned before, the introductory method we learned about. But now, what if you're faced with a function like y equals to 2 plus 3x to power a 4, 1 minus 3 to power a 2, 1 minus 1, x minus 1 to power a 2. How easy is the expansion of this? How easily can you expand this? Okay, you realize that it is a bit difficult to expand this. These high powers, 4 seems to be a high power you can expand, but it takes a lot of time. It may take a lot of time. So in that case, we think of what we call the product rule. A product rule, from the word product, we have a function that is a product of two functions, okay, that are functions of x, and we use it like in this case when you cannot easily expand. For such a number, you may not go for product rule because it is very easy to expand, but for this one, it seems a bit difficult or hectic or big to expand. So what we do, we use product rule. So in product rule, we let those products, the terms or the factors to be some variable. For example, we let always y equal to a new function u, which is of course a function of x, times v, which is also a function of x. Remember, we said we're multiplying two factors, so let one be u, let the other be v, and in such a case, you have a u, you have a v, you get dy dx, du dx, you also get dv dx, and the derivative of such a function will be equal to v du dx plus u dv dx. This is what we call the product rule. Let's look at examples. Example number 1, we're going to look at these very examples here. Start from those ones. If you had this y equals to x plus 1 into 2x minus 3, it is a product. I can let my u to be equal to x plus 1. We said when you let u, let it give you du dx. What is du dx? You know it is a 1, because when you differentiate this, when we said if it is a linear function, the power of x is 1, then you just take the coefficient of x, which is 1. Then this is a constant, its derivative is a 0, so we have that. And then let your v, of course, to be the other function, which is 2x minus 3. So this one gives you dv dx. What is dv dx? It is 2. Okay, now if you have that, remember what we've said, that from the product rule, dy dx is equal to v du dx plus u dv dx. This is a u. Okay, so we just substitute in this formula. What is our v? Our v is this, 2x minus 3 times du dx, which is a 1, plus u. What is our u? Our u is x plus 1 times dv dx, which is a 2. And this gives us 2x minus 3 plus, we can expand this to give us 2x plus a 2. So when you expand further, this one will be, you add, this gives you 4x, then this one remains minus 1. And that is it. Number 2, when we had y equals to x squared plus 1 into x squared. Okay, so we begin by letting, what is your u? It doesn't matter which one you let to be u, but let me let this to be u, and then my v to be equal to x squared. So this one we said gives us du dx, which is equal to 2x, and this one gives us dv dx, which is equal to 2x. Alright, so when we go to our formula, dy dx, we said is equal to v du dx. Don't forget, we start with v. Let's start with v so that we don't get confused when we go to, there is another method about the quotients. I advise we start with always a v so that we don't mix up things. Though even when you swap, it remains the same. Okay, let's substitute v. What is our v? Is x squared into du dx, which is 2x, plus what is our u? Our u is x squared plus 1 into dv dx, which is 2x. So when we expand this, this will be 2x cubed plus 2x cubed plus 2x, which gives you 4x cubed plus 2x. You can try out this by expanding this and differentiating and see whether you end up with this. Alright, let's look at another example. Number 3. If you have your y equaling to 2 plus 3x power 4 into x minus 1 squared. This is one that really requires the product rule. So let your u be equal to 2 plus 3x power 4. And when we differentiate this to get du dx, Here we use chain rule, but I'm going to work it out easily, but what I'm using is chain rule. Okay, so this will be a 3 times a 4 into 2 plus 3x to power 3. How we can use chain rule easily without substituting the formula, because you'll need this over time. What you do, differentiate what is in the bracket. What is in the bracket is 2 plus 3x. When you differentiate it, you get a 3. Put a 3 out. It is here. So times. Now drop the power of the bracket, which is 4. It comes down, and then you write the bracket and you give it a new power as a 4 minus a 1, giving us a 3. That is what you can do, and that is in brief chain rule. So this is 12 into 2 plus 3x cubed. Let your v to be equal to x minus 1 squared. So to get dv dx, we use the same method, or you can start by dropping the power, which is 2, multiply by the derivative of what is in the bracket. What is it? When you differentiate x minus 1, you get a 1. Then into that very bracket, now reduce the power by 1. Like we are differentiating, assume there is just maybe x, the whole of this is x. So just reduce a 1, by 1 here, so remaining with the 1. So this gives you a 2 into x minus 1. Alright, now we substitute in our formula. dy dx, we said is equal to v du dx plus u dv dx. So what is our v? Our v is x minus 1 squared times our du dx, which we got as 12 into 2 plus 3x to power 4, not power 3. Okay, then plus u. What is our u? Our u was 2 plus 3x to power 4, yeah, times dv dx. What is our dv dx? Our dv dx is 2 into x minus 1. Can we simplify this a bit? This will be like 12 x minus 1 squared into 2 plus 3x cubed plus, this will be 2 into x minus 1 into 2 plus 3x to power 4. Now we can take out some common factors here. I see 2 is a common factor because there is a 2 here, there's a 2 here. I'm seeing x minus 1 is a common factor. It is here, it is also here. I see 2 plus 3x to power 3 as a common factor, because the least power of 2 plus 3 in these two terms is 2 plus 3x cubed. So meaning it is a common factor. This one is power 3, this is power 4. So it means this one also has a 2 to power plus a 3x to power 3. So what do we remain with here? This one remains a 6 x minus 1, because this one has reduced by 1, and this one is not there, it is already out. So plus, what remains here? Remain with just this 2 2 plus 3x. Yeah, because we removed the 2 plus 3x to power 3, so we remain with 1. When we simplify, this will be 2 into x minus 1 into 2 plus 3x cubed into, this will be 6x minus 6 plus 2 plus 3x. Yeah, we can simplify further, giving us this 2 plus 3x cubed into, this is 9x minus 4, and that is it. You can imagine how you would get such after expanding. Alright, let's look at another example here. Number 4. If you're given y equals to x squared plus 1 over x plus 1 squared, I want us to apply product rule here. Later on we shall take this to quotient rule, but we can also use product rule here. How would we make this a product? We have to first make sure you make it as a product. So meaning I have to take this denominator up. It gives me x squared plus 1 into x plus 1. You know, when it goes up, this becomes negative 2. It becomes a negative, the inverse of this. Okay, so at that point it's now a product. You can let this be your u and this to be your v. So meaning my du dx will be equal to 2x, my dv dx will be equal to, we said drop the power, negative 2, times the derivative of this bracket, which is 1, then times that same bracket with a reduced power, minus 1. So which is negative 2 into x plus 1 to power negative 3. So we substitute in our formula, dy dx is equal to v. What is our v? Our v is x plus 1 to power negative 2 times du dx, which is 2x, then plus u. What is our u? Our u is x squared plus 1 times dv dx, which is negative 2 into x plus, there's a 1 here, plus a 1 to power negative 3. Okay, now we simplify. So I can write this as, we can take this down, we write it as a fraction. So this will be 2x over x plus 1 squared, plus we do the same here, this will be x squared plus 1 over, or there is a negative 2 here, can put it here, negative 2 over x plus 1 cubed. So this equals to, let me first write this expression here, which is 2x over x plus 1 squared minus 2. Now it has become a minus because there are the positive and then a minus on 2 into x squared plus 1 over x plus 1 cubed. Alright, now we simplify this. We can take the LCM. to be this, which is x plus 1 cubed. And when we divide this by this, we end up with x plus 1 into 2x minus this divided by this, so 1, end up with this x squared plus 1. When we expand, this will be 2x squared plus 2x when this one enters the bracket minus 2x squared minus a 2 over x plus 1 cubed. And this gives us this remain, these ones cancel out, so we remain with 2x minus 2 over x plus 1 cubed. We can write it as this, x minus 1 into, over x plus 1 cubed. And that is it. That is our answer. Okay, lastly, we can look at another example. If you have y equals to root of x plus 2 times root of x plus 3, let this be your u, let this be your v. We say it doesn't matter which one you let to be u, which one you let to be v. So meaning your du dx will be equal to, remember we've let our u to be equal to a square root of x plus 2, which is the same as x plus 2 to power a half. So when you differentiate, the half comes down. Differentiate time with the derivative of the bracket, which is 1 into x plus 2 to power, when you subtract the 1, it becomes negative a half, which we can write as 1 over 2. When this one goes down, it becomes x plus 2 to power a half. Okay, now get the v dx. The same thing, our v is equal to x plus 3 to power a half. So when you differentiate, the half comes down times the derivative of the bracket, which is 1 into that same bracket with a reduced power, which is negative a half. When you simplify or when you organize it, it becomes 2 into x plus 3 to power a half. Substituting in our formula, dy dx equals to v, where is our v? It is x plus 3 to power a half. Du dx, what is our du dx? It is 1 over 2 into x plus 2 to power a half plus u, what is our u? It is x plus 2 to power a half times the v dx, which is 1 over 2, 2 into x plus 3 to power a half. Okay, if I rewrite this here, it will be the same as x plus 3 to power a half over 2 into x plus 2 to power a half, then plus x plus 2 to power a half over, this is a 2 into x plus 3 power half. Alright, what is the LCM here? I can take out this half here, the half, because there's 1/2 here, 1/2 here, so that I remain with the LCM to be the product of these denominators, power half into x plus 3 to power half. Now, when you divide, what do we get? Divide this by this, you get this, remain with x plus 3 to power half, but times the numerator, which was also x, plus 3 to power half, plus when you divide this by this, you get x plus 2, you get x plus 2 power half, times what remains, what was in the numerator, which is also x plus 2 to power half. Sorry about this, but this is the same as a half into, if you look at these are the same bases, meaning we can add up the powers, so remain with x plus 3. The same here, these bases are the same, we can add up the powers, half plus half, which is a 1, end up with x plus 2 over x plus 2 to power half into x plus 3 to power half. So writing it in a better way, this will be like a half into, this will be 2x plus 5 over x plus 2 to power half into x plus 3 to power half, which I can write as 2x plus 5 over, most of this work is just simplifying. You should be good at simplifying and algebra so that you can always come out with a good answer. Yeah, so that is it. That is the answer. Someone may go on and use the root signs in the denominator as it was given in the question. X plus 2 into square root of x plus 3. Yes, thank you for watching. Don't forget to subscribe and to share. If you have any questions, put it in the comment section. See you.